Good morning. Welcome to AP Computer Science A. Today we are going to be covering section 3.7. In section 3.7 we are going to be comparing objects. We talked about memory before. We talked about the stack and the heap memory. So if you notice, some of this material should look familiar. So today we are going to continue covering comparing objects like we've done it before. So make sure that you guys have your notes ready. Make sure that you have your REPL ready to go. Make sure to type in your name and don't forget to click submit so you can get credit for this assignment. Now, let's go and start getting user input. So therefore, in order to be able to get user input, we need to be able to import the class scanner, which is within the utility package in Java. And now that we've done that, then we can declare and initialize the variable scanner. It's going to be scan. It's going to be a object of type scanner that is declared, and now we're going to initialize it, and we're going to get input from the user. So therefore, and we're going to use the keyboard. From there, we are going to ask the user to type in two integers. Please scanner system enter two integers. Then we're going to store them in A1 equal to scan. That'll be the object name. And now we can actually access all the methods from the scanner class. The one that we need is next int, because we are getting an integer. And now let's get another one, A2 equal to scan next int. And now let's go and compare them and see if they entered the same one. So let's go and say if A1 equals, remember that for comparison we need a double equal sign. System.out.println. In this case, I'm just going to have one statement, so I don't need my braces. But most of the time, it's a good idea to have them. For now, let's go make it a little shorter and say same. It says same input. So therefore, if they both have the same, it's going to print out same input. And now else system. If they're not the same, that means that they are different. And we have. Let's go run it. And they're going to have two numbers. So let's go and type in a 5 and a 5. Same input. Makes sense, right? Let's go and run it. Let's type in a 20 and a 15. Different input. Let's go and run it. Let's go and type in a 10 and a 10. Same input. So that is logical, right? We type in the same thing. But now let's go and go through and have the user type in two strings. So therefore, we need to be able to change this to string. We're going to use the other method within the scanner class called getLine. And let's go and change this to string. So therefore, the user is now going to enter two strings, and we're going to decide if they're the same or different. From now, we're going to enter two strings. Let's go and enter Santa Fe. Santa Fe. Did I misspell it? S-A-N-T-A space. Yeah, it seems to be the same, right? And so what happens? Good question. I'm glad you asked that question. So therefore, if you guys remember, so this is my dog. This is my dog, Ivan. Ivan is 15 years old, so he might see him pacing a bit. So just I apologize for that today. He's getting a little old and a little senile, just like Mr. Diaz at times. So therefore, what happens? So if I go back to the previous example, whenever Java compares items, for example, if we compare the first, and let's just say this is A1, and now we create another one just like on the previous example, and we call this A2. Whenever Java compares with the double equal sign, it's only comparing things in the stack. So therefore, it said, is 5 equal to 5? Yes, then that's true. But if we are going to create a, let's go and run it, and let's go and type in Mike. So we can have Mike and Mike, different inputs. So what happens is that Java is going to create the first one, and it's going to create Mike. And remember that this is the hashtag, basically just the memory location where it's stored. And now whenever we create another one, we want a different one. It's going to create another string, and we're going to connect them. And now the memory location is going to be different. So therefore, whenever we're asking them to compare with the double equal sign, it's only going to compare the memory location. In this case, are those two equal to each other? No, they're different. So it's not going to compare the actual objects. Remember that whenever you create an object, in the stack, the variable is only going to hold a location to the memory location. It's going to be the hashtag, and this is A2. So whenever we ask it, are they going to be the same? That is going to be a no, they're different, because it's not going to look at this, the actual string. It's actually just going to look at these numbers that are in the stack, which are the hashtag, which most of the time will reference the memory location. So how can we fix it? That is a good question. So in order to fix it, we are going to actually just going to use the method that equals that we talked about briefly before. And now this method is actually going to go through and compare the objects themselves. And now I can run it. And now I'm going to type in Mike, and now they have the same input. So every single time you are comparing two objects or two variables that are of non-primitive types. If they're primitive types, whether they are ints or if there happens to be, do you have any doubles in here? Or if there happens to be doubles, then that's fine. If they have to be Boolean, it's fine. We can use a double equal sign. But if they happen to be strings, that is a non-primitive type. Then we cannot use a double equal sign. So that's something that you need to keep in mind. Every time you compare strings, you must use dot equals to compare. Even if I compare A1, and I'm just going to take in one input, and I say, I'm going to see if it's, let me go back and say A1, I want to see the user type in Mike. This is equal to Mike. And let's go and run it and see what happens. What do you think is going to happen? I want to type in Mike, M-I-K-E. They're different inputs, but they're the same. That is because it's going to be comparing the memory location. Is that part, is that equal to Mike? No, that's at F5, 6, 7, 8, 9. So therefore, in order to be able to compare to see if the user actually typed in Mike, we have to say equals and place the Mike inside the parentheses. And now we can run it. And we can say Mike, semicolon. So if you're going to be comparing two non-primitive types, you must use dot equals. Repeat after me. If you are comparing two non-primitive types, you must use not equal. Repeat after me. If you are comparing two strings, you must use dot equals. And I know what you're going to be saying. I say, Diaz. But let me try something new. Let me go ahead and get rid of this. And you're going to tell me that few times that it works. So we're going to say string A1 is equal to Santa Fe. Then you're going to say string A2 is equal to Santa Fe. Now, you're going to say A1 is equal to A2. And what's going to say? Should be, they're going to say, oh, it does work, yes, so why do I need to do the equals? Well, sometimes Java is so efficient that in this case, if you create, if you create one string right after the other, there's going to be times that it's going to say, oh, hold on, you already created the first string. So when you create the second one, I'm just going to use the same one that I just created. So there's going to be, and I'm just going to give it the same location. Why am I going to work so hard and create another string if I already have one that's called Mike? So if I have one that's already called Mike, and I need another one, and you just create another called Mike, Java is going to say, why do I need to go through a hassle of creating two different ones if I can just go into the same one? So there's going to be very few occasions that a double equal works, but you don't want to use, repeat after me, when you compare strings, you must use dot equals, and that is going to be on your AP exam because that is an essential part of Java. Any questions? Now, since we are here, let's assume that we have A1 and we have, we're going to create a new string and we're going to just say A1. We have, if we do a double equal sign, is that going to work, yes or no? Because whenever you are copying, so in this case, let me just go back over here and pull this one back. So in this case, we are only creating a one string called, and let's go and call it Mike. So if I say Mike, and whenever I create one string Mike, that's what's going to happen, correct? Now, whenever I place A1, assign it to A2, whenever you do the assignment operator, not an equal sign, you're not saying equal, remember that whenever we talked about this being read, A1 is going to be assigned to A2. What is going to happen is going to create, on this part, is going to create a new one, and it's going to copy. Right now, it won't have anything yet, but whenever you copy this out, it's going to take the values in the stack, and it's going to copy them over. And therefore, it is going to point to exactly the same one. So therefore, if I run it, it should be same. Input. So whenever, and we'll talk about this in a few more minutes, whenever you do an any A1 to and assign it, you are basically just copying the contents of the stack from here to here. That means that you are copying the location of the memory location, and therefore both of them are going to be pointing to the same thing. Whenever you're dealing with C++, they call them pointers, and people get quite confused with this concept. This is what throws a lot of people off in computer science and in programming. You need to be able to understand that whenever you have an equal sign, you are not saying A2 is equal to A1. You are reading it backwards. A1, the values in the stack, is being copied to A2. But because the stack is only holding the memory location, that's only being copied there. Therefore, they both are pointing to the same value. So therefore, that's what the only reason. But it should not, repeat after me. Whenever using strings, you have to use dot equals. Even in this few cases that it works, just use dot equals. It's going to save you a lot of headaches. It's going to give you that 5 on your AP exam. And you say, well, hold on, yes, I want to get the same thing. Why do I need to bother? Every time you use strings, you have to use dot equals. Now, one of the reasons that I left the circle class in here for you. Now let's go and create a circle. Now let's create another object. So now we're going to use circle. Let's give it a name, C1. Perfect. A new, we're going to call the constructor. Now, if we look at the circle, they has different constructors in here. You have one, no, this is the class. This is the name of the class. This is the name of the circle or the constructor, and it has two constructors. What do we call when we have two constructors that have different signatures? That is overloaded. So those two constructors, do we have a third one? No, that is a set radius. So therefore, we're going to use this constructor here, where we're going to actually give it a double as the radius. So therefore, it'll be circle, and let's go and say 5.2. Perfect. A double. Now let's go and create another circle. Circle C2, new circle 5.2. And now we want to be able to compare to see if those circles are the same. Well, they're both 5.2, so they are the same. So let's go and say if C1 is equal to C2, system.out.println semicircle, or circles are equal. Else system.out.println circle are not equal. And let's go and run it. And but they're both 5.2. Shouldn't they be equal? I create a circle, another circle. Correct. Repeat after me. Whenever you have a non-primitive types, you cannot use a double equal sign. You have to use dot equals. Because in this case, it's happening the same thing that happens with the string. So let's talk about that. So in this case, let's go and assume that this is a circle. So now, so we do have a circle. So let's go and say illustration, and I'm just going to add a circle, and I'm just going to add it here. Oh goodness. Illustration, shape, and I'm going to add a circle. So let's go add a circle. And now we are going to add another circle with the same shape. And now because once we create the circle, they're going to be pointing to different locations. So therefore, that circle is located here, and that circle is located there. And that is going to be the location of the circle. So whenever we compare with the double equal sign, it's not going to compare it. But whenever we compare it with the dot equals, right, a double equal sign is comparing these two numbers, the memory location. Because it's not primitive, the stack only holds a memory location. So therefore, that's why we get a, if I do this part, that is why I get a circles are not equal. Even though we see them as being exactly the same, they both have a radius of 5.2. It's not equal. So in order to be able to compare two objects, we must use dot equal. If we're going to compare two non-primitive types. Now, what happens whenever we are What happens when we are using a die equals? Whenever we're using a die equals, we actually are, and that's why I left the class there for you. We actually are going to go down to the equals method. And basically, sometimes they have a little more challenging process. I kind of simplify it for you so you can see it. But basically, just doing this. It's comparing the radius of the original one versus the radius of the one that you send it in. And if the equal is going to return true, otherwise it's going to return false. And that's basically what's happening. In this case, this is the one that you are sending in, and this is the original. So the C2 is the one that you're going to send in, which becomes C. And the radius is the one that you actually are sending. But we're going to talk more about classes once we get to Unit 5. Now, one more thing that I want to go over. I'm just going to print them for now. Well, actually, if I place one circle, and instead of constructing the second one, I'm just going to say no. I'm just going to say C1. I'm not going to system the print ln C1. What's going to print for the first one? Remember that whenever we just print the variable itself, we actually are going to be using the toString method, and this is what's going to print. But we don't have to do a toString. Java automatically knows that we need to be able to, that's going to call that method. Correct? But what happens in memory? So what happens in memory is that we are constructing the first circle. We are constructing the first circle, and that's this is C1. And once we construct the second circle, C2, whenever you, this is an assignment. So basically you are going to copy the values of what's in the stack, and therefore it's going to point to the same circle. Correct? And that's why it's pointing the same thing. So what happens if I change? I'm only going to change C2. C2, I must set the radius to something different. I'm using the set radius method, which is here. And where's my set radius method? Okay, radius, set radius, get radius. Set radius is going to take a double. It's going to change the value of the radius. Once is and notice that your set radius is a void method. It doesn't return anything, so I need to catch it. I don't need to save it anywhere else. I'm going to set to, I'm going to change the second one to 1.5. And I'm going to print it. So notice that now they both got changed because they're both pointing to the same circle. The fact that I shrink it, they both are pointing to the same circle, so they both are going to be the same. So you have to be careful. They're both pointing to the same exact circle. So if I change C1, C2, both of them get changed. Now let me change C1 now. C1 set radius to 9.8. What's going to happen? What's going to be the radius for each one? C1 should be 9.5, C2 should be 1.5. By reality, because they're both pointing to exactly the same object, correct? That means that if I make this huge, they're still both pointing to the same object, so therefore you actually are changing both of them at the same time. So that's something that we need to be aware, and we're going to continue talking about it. It's not going to be on your test yet, because we still need to build on that knowledge. And I know that you're going to be saying, hold on, Diaz, let me think about something else. And there's going to be things that we are going to be thrown off at times. So sometimes when we are working with strings, strings are slightly different. So let's say that we have a string, Mikey. and we have the same concept. So let's go and build a string, and just to throw some of you guys off, if this is not, and we're going to say A1 is going to be Mike, and now I'm going to say string 2. I just want to make sure that I'm thorough in all of the explanations. You need to be able to understand Java. There needs to be a good conceptual understanding of memory in order to know what is going to happen. So actually, I must say Mike, and then I must say A1. So same thing that we covered before, right? Same example as before. We have this here, and they're both pointing to the same, and this is the memory location is F56789. So do you guys agree that so far we have the same example as the circle? Let me go and print it. Oh, nothing. First of all, it's going to give me an error. Stop. Sometimes I like to copy and paste before I refresh, because sometimes I'll delete my whole code. That is not very nice. Okay, let's try again. Let's go and run it. They both are mic, right? Now let me do the same thing that I did before. So I'm going to change A2 to DS. A2 is equal to DS. What do you think is going to be printed? DS and DS? Let's try. No, it doesn't. You're going to say, hold on, DS, that makes no sense. This is not what you told us. Well, what happens is that we talked about strings being immutable. What does immutable mean? Immutable means that it cannot be changed. So therefore, what happens is because they cannot change this, it's going to create a whole new string, and it's going to be DS. D, I, A, Z, lowercase. And now it's going to assign that location. So therefore, it's going to change the location G because strings are immutable. This string cannot be changed. Therefore, it's going to make a new one. The same way that if I make A1 to be Dave, we talked about this before. If I change it, what is going to happen is going to take this, it's going to make a new variable somewhere over here. Let me move this up. And it's going to make a new variable, Dave. And what's going to happen? It's going to, one more. It's going to point to the new variable, and it's going to change the memory location. So now it's going to be 80. And the memory location is going to be 80. So therefore, whenever I print it, strings are immutable. That means that you cannot change the object itself. And what's going to happen to this? Do you guys remember what happens to this here? The trash collector. Java has an automatic trash collector that's going to take care of it and say, you're not using that anymore, so therefore I can just get rid of it. Now, in C++, in other languages, you actually have to destroy them, because otherwise it's going to start collecting more memory, and that's when you run into issues where your computer is just getting flooded and using all the memories. That is because there are memory leaks, and that's because Java, C++ does not have a trash collector automatic, and you have to destroy them. In this case, Java does it for you, which is great. I know that this is a lot of concepts to understand, but hopefully that helps. We're going to continue working with memory, Java memory, in the next few chapters, few units. So have a great day, and I'll see you guys next time. And my dog continues to be low senile, just like Mr. Diaz is getting. So have a great day. I'll see you guys next time.